this. My first example that I'm going to work on is I have a diagram that shows two adjacent squares. Find the area of the region R. Okay, so if I look, here's my little square. It's a 4 by 4. Here's my big square. It's a 6 by 6. And adjacent just means that they're side by side. Okay? What we are looking for is we're looking for this little region right here. Region R. So I'll shade it in. There it is. So what we could do is we could first look and think to ourselves, well, I can find the area of this entire figure, both squares together. So that's what I'm going to do. So I'm going to first find the area of the big square, and then I'm going to add it to the area of the little square. So I'm going to call this area total. So my big square is 6 times 6, and the little square is a 4 by 4. So my total area that I'm talking about is 36 plus 16, which is equal to 52. Alright, once I find that, I can think to myself, well, I can find the area of this big triangle right here. And we'll call that triangle A. So area of triangle A is equal to 1/2 its base. Now its base is 6. Its height is 6. So that means half of 36 is 18 meters squared. Okay? But I can also look over here, and I have another triangle that's formed. They're both right triangles. So I'll call this triangle B. And so the area of triangle B is equal to 1/2 its base. Its base is 10. Its height is 4. So that's equal to 20. So that means that the area of the shaded is going to be my total area minus those other two. So I have my total area, so that's equal to 52, and I want to minus the area of A and B, so that's 18 plus 20. So we have 52 minus 38, so I'm left with 14 meters squared. So that is how you find the area for my first example. Okay, so I have another example. Example 2. We have a diagram that shows several triangles in a rectangle. If the area of region R is 16 square centimeters, find the total area of the regions S and T. So first of all, they're telling us that region R is equal to 16. Alright, so we are looking for the total of S and T. So first of all, what I want to do is I want to find the distance right here. And I'll call that X. So I know that the area of a triangle is 1/2 base times height. So my area is 16, so I'm just going to do some substitution. 1/2, my base is 8. And then my height is X. So 16 equals 4X divided by 4. So I have 4 is equal to X. So that, in other words, my height is 4 plus 3 is 7. So this is not a perfect square, even though it looks like it. Okay. So now what do we do from here? Well, let's think about this for a minute. I can find the area of my big right triangle here. So I'll call this A. So I want to first find the area of triangle ACD. Okay, so the triangle of ACD is equal to 1/2 its base. Its base is all the way, which is equal to 8. So times 8 times its height is 7. So this is 28 centimeters squared. So that's my big triangle. But now I'm just going to look at the piece, and I'm going to label it U. Because what I'm going to do is I'm going to take this piece out of it. Well, that distance on the bottom is 3. So area of triangle U is equal to 1/2 its base times its height is 7. And that's equal to 10.5 centimeters squared. Alright, so now I have my big triangle, which is ACD, and I am going to subtract the little piece that I don't care about, which is triangle U, and that will give me the shaded. So area of S and T is equal to my total area, which is 28, minus 10.5, which is equal to 17.5 centimeters squared. Alright, so those are a couple examples that are using areas of triangles.